Hey guys, so this video is basically just using taking more examples and then using the continuity test to try to figure out if functions are continuous or not. Okay, so we're going to take a look at these two examples here. We have f of x equals x plus 3 over x squared plus 6x plus 9. And we're trying to figure out if it's continuous if x is negative 3. So the first test of continuity basically says that f of negative 3 has to exist. Okay? Now the thing is, you want to make sure that you are plugging into the simplified version of any reciprocal function like this is in this case. Okay? So we want to go ahead and factor the bottom. And what we'll see is the x plus 3 and the x plus 3 cancel out, and you'll have a 1 over x plus 3 at the bottom. Okay, so that's what I want to plug in negative 3 into. So when I do that, I'll get 1 over negative 3 plus 3, which is 1 over 0. And if we recall, anything over 0 is undefined. And if something is undefined, then it cannot exist. So because f of negative 3 is undefined, that means it doesn't exist. That means it is discontinuous. And what type of discontinuity we're going to have? Well, since this is a reciprocal function, that means the denominator cannot be 0. And if I set x plus 3 equals 0, I'll get x is negative 3. That means at negative 3, there is a vertical asymptote, which means that when x is negative 3, I have infinite discontinuity. Because infinite discontinuity is when you have vertical asymptotes. Let's look at the next example. Very similar to the one I just did, but this time I flipped it. So just like before, we're going to factor. And we're going to simplify before we evaluate at f of negative 3. Okay? So we see that the x plus 3's cancel out again, and this time I'm left with x plus 3. Not 1 over x plus 3, but just the x plus 3 at the top. Now when I plug it in, I have negative 6. And negative 6 does exist. It's a real number. So the first test is good. Now the second test says to take the limit as x approaches negative 3 from the left and negative 3 from the right. Now this is actually very easy to do here, because all I have to do is I take the simplified form and try to figure out what type of function is this. Well, x plus 3 is actually a linear function. And yeah, I got that linear function when I simplify, but nonetheless, that's what it's going to look like. It's going to look like a line. And with lines, no matter what value, okay, x is, when you're approaching from the left and from the right, you're going to end up approaching the same number. Okay? So, as you're approaching from the left and the right, it's going to approach still negative 6. Now, the third test says that f of negative 3 and the limits as they're approaching from the other side have to equal the same thing, which they do. But this is one of those cases where this is actually discontinuous. And the reason why is because if you simplify and you end up canceling out a factor, which we did at the very beginning, that means there is actually a hole, or in this case, point discontinuity or removable discontinuity at negative 3. Anytime you have to cancel out a factor and the solution to that factor is what's given to us, then you have a hole or removable discontinuity. All right? Let's look at another example. Okay? I believe I got through A in all my classes. B, I don't think I did. B is a quadratic function. And we talked about quadratic functions before. Quadratic functions look like a U, and at any point in time, am I ever going to lift up my pencil? I'm not. So all quadratics, no matter what x is continuous. Okay? Think about it. If I do f of 4 and I plug it in, I end up getting 39. And wherever 4 is located on the quadratic, I'm always approaching that y value from the left and from the right side. The only functions you really have to worry about not being continuous, or where you really have to check using the continuity test, are your reciprocal functions. That's when you have a variable in your denominator. Your greatest integer functions, because those of course are your steps, and your piecewise functions. Okay? So any of those you have to check. Other than that, they're all going to be continuous. I hope this extra video did help. If you guys have questions, you can always shoot me an email, but definitely make sure you finish up problems 1 through 4 on your homework so we can go over them tomorrow, okay?